And we're back! How are you? Now, let's consider these two new functions. We have f of x being x squared minus 2. And we also have g of x being the square root of x minus 2. We are going to show the composite results or composite functions of these given functions here. Let's start with this notation. You have f of g of x. When you see expressions like this, you are going to take the function of f or f of x, and instead of x, you will be taking the value of g of x as the new value or variable of x for the f of x function. We're talking about like this. Supposedly, your f of x is x squared, right? Again, let's do it like this. Your f of x is x squared minus 2. So you have x squared minus 2. Now, we are going to remove this x, or not remove, we're going to change this into the g of x. And we know that g of x is square root of x minus 2. So you will have it like this. You will have parenthesis. It's very important to include parentheses because there might be notations or just like exponentiation here, and for some cases numerical coefficients that will be used to simplify it further. So again, g of x is square root of x minus 2. And take note that f of x is originally x squared minus 2. Notice this should be our x earlier, x squared minus 2. But the value of x became g of x, which is square root of x minus 2. Now you don't need to worry about the radical expression there because you are taking the square of the radical expression. Therefore, you are going to cancel them out. This would mean that the result of this is just simply x minus 2 without the radical expression. No more radical expressions, no more exponentiation because you have canceled them out. And then you will have minus 2 here. Now you're going to finalize this by removing the grouping symbol, and you can do it without any problem because there's no other numerical coefficients here aside from 1. So you'll have x minus 2 and then minus 2. In short, f of g of x using the two given functions is x minus 2 minus 2, that's minus 4. This is the result for the f of g of x. Now let's proceed to the second, g of f of x. So conversely, you will be having g of x, but instead of the variable x, you will have f of x here. Just like that. We know that our g of x is the square root of x minus 2. Again, square root of x minus 2. But since we have this composite function, the x there becomes the entire function of f of x. And we know that f of x is the expression x squared minus 2. And you will have it something like this here. So with that, we are going to simplify this by starting with the radicand. So we are going to take still the square root as it is, removing grouping symbol without any problem. You'll have x squared, and then you will have minus 2. And then you will have another minus 2 here. So your result is square root of x squared minus 4. Now there are some misconceptions as to this. Some might say the result is actually square root of x squared, x square root of 4, 2. This is not the case here because x squared minus 4 is a polynomial as a whole. You cannot take the square root of the first term and the second term for a binomial expression like this. Because x squared minus 4 can be rewritten like this. Let me have it here. Written as, that's the difference of two squares, x minus 2 and x plus 2. See that we don't have a perfect square expression here. It's not x minus 2 times x minus 2 because it will become a perfect square trinomial. This would mean it can no longer be resulted to this. This is already our final form of the g of f of x. These are now the results for the composite functions with one of the functions being a radical expression. That's all for today. You're dismissed. And please do not forget to subscribe now.